Latin, means literally cloud or fog. As a matter of fact, they are agglomerates of interstellar dust, hydrogen, helium, and other ionized gases. When were they first discovered? The first time that this term was used, probably without a rigorous classification, was in the 150 AD by Ptolemy, that used it to describe a group of 5 stars. Later on in 1610, the Orion Nebula, one of the brightest ones in the sky, was first discovered by using a telescope. Successively, Edmund Halley, the one linked with the worldwide famous comet, firstly published a list of 6 nebulae in 1715. After that, the number of observations grew quickly and was gathered in a catalog of nebulae and star clusters by William Herschel and his sister Caroline Herschel. This definition was incorrectly used to describe any possible kind of cloud, and a famous mistake was made regarding the Andromeda Galaxy, which was known as Andromeda Nebula until the early 20th century. More precisely, the so-called Great Debate took place in 1920. What was it about? It revolved around the nature of a group of spiral nebulae. 2 astronomers called Harlow Shapley and Herbert Curtis had 2 different views about the distance of these objects, and the scientific community was struggling to take a solid position in the discussion. The first one thought that these clouds lay just at the outskirts of our Milky Way, while the other was sure that in fact they weren't nebulae, but independent galaxies separated from ours. Thanks to the important contribution of Edwin Hubble that was able to measure the distance of the Andromeda Nebula, scientists understood that Curtis was right and that Andromeda was a separate galaxy. What can you see from a photo of a nebula? It surely appears to be a really dense and thick, like a cloud of dust. But here is a surprising result. Even if they are denser than the space around them, they are so far less dense than the usual world we live in that any vacuum created on Earth is surely denser than them. A nebula with the size of our planet would weigh just a few kilograms. How are all nebulae formed? They can be created both by interstellar medium, by stars, or by the rest of a supernova. In fact, there is a wide list of different types of nebulae, depending on the formation and the characteristics of the cloud. Do you know some of them? If not, don't worry. In this video, we'll see the 5 most important types of nebulae. Before finding out more about this, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel, clicking the bell so that you don't miss any of our weekly videos. Let's start from the classification of the Orion Nebula that was previously mentioned. It is known as one of the most famous H2 regions. What are they? They are mainly characterized by the presence of a 90% of ionized hydrogen and by their shining red color. These 2 things are strictly linked, as any kind of ionized hot gas usually emits light at precise wavelengths. In physics, the density of energy emission per unit of frequency or wavelength is called spectrum. That can be considered as a catalog of the frequencies of the radiation. The one of ionized gas is called emission spectrum, and it is mainly composed of some lines typical of each element. Let's see if you have followed my thoughts. H-alpha emission line of hydrogen is nearly around the value of 656.3 nanometer. Do you know what color it corresponds to? Yes, exactly, red. H2 appear red due to the presence of its ionized hydrogen. But what is the cause of this ionization? In these regions, there is a huge abundance of short-lived blue stars that lighten the gas producing the emission lines. But where are these types of nebulae usually located? Have you ever seen those beautiful images of spiral galaxies like Andromeda or our Milky Way? H2 regions are mostly contained in the typical branches of these structures. Although these nebulae can give birth to thousands of blue stars in the time span of 1 million years, they're usually dispersed by supernova explosion, an event that occurs at the end of the life of a really massive star. The second type we are going to describe is the planetary nebula. Don't let the name confuse you. It doesn't have any link with planets. Given by William Herschel, this definition derives from its spherical shape. In fact, in 1979, the French astronomer Antoine Darquet de Pellepoix described in his observations of the Ring Nebula, very dim but perfectly outlined. It is as large as Jupiter and resembles a fading planet. These particular nebulae are formed by the remnants of a supernova of intermediate stars, between 1 and 8 solar masses. These last ones, like the Sun, spend major parts of their life converting hydrogen into helium, period also known as main sequence, which is then turned into carbon and oxygen. The second phase of the nuclear fusion is called as the asymptotic giant branch phase. In both cases, the reaction in the core of the star generates an outward pressure that balances the gravitational contraction. During the giant branch period, the star loses mass due to stellar wind. These materials emitted in the surroundings of the star can be enlightened by the burning stellar shells of hydrogen and helium that can reach around 30,000 Kelvin, an appropriate temperature to emit ionizing ultraviolet rays. How do planetary nebulae die? When the core of the star consumes all the burning helium, it doesn't have enough energy to convert oxygen, and so it stops the nuclear fusion. As a result of that, no more UV radiation is produced, and the nebula fades away, becoming invisible to us because the gases aren't ionized. Did you know that planetary nebulae are very important? Why? In these clouds, there's a huge abundance of metals created by the star. These elements are not so common in the universe, which is usually composed of hydrogen and helium. Moreover, planetary nebulae are surely the most various and spectacular ones, with a wide range of shiny colors and crazy shapes. Do you want an example? Search for the Cat's Eye Nebula or the Ring Nebula. To resume, these last two types can be gathered in a single category of emission nebulae. They are composed by ionizing gas that emits in different wavelengths depending on the elements of the cloud. Moving on, let's examine the third type, the reflection nebula. As opposed to emission nebulae, these ones don't emit radiation by themselves. As the name suggests, they just reflect the light from an external star. Do you want a simple comparison? When you see a marble cave, you're blinded by the light that comes from the rock. But that radiation is not produced by the marble. Instead, it is just the sunlight reflected and directed towards our eyes. The most famous reflection nebulae are located around the biggest stars of the Pleiades cluster, one of the most visible ones. This type of scattering always produces a blue light, since this wavelength results more efficient in the reflection. This process is also called Rayleigh scattering, named after the 19th century British physicist Lord Rayleigh, and often occurs when we have a particle much smaller than the wavelength of the radiation. It is possible to find that power of light diffusion is proportional to the inverse of lambda to the power of 4. As a consequence of that, blue, which has a smaller wavelength of 500 to 520 nanometers, is reflected much more strongly than red, which has a greater wavelength of 700 nanometers. This is the main reason why our sky happens to be blue, as the particles in our atmosphere interact with sunlight according to Rayleigh scattering. The same exact phenomenon happens in reflection nebulae. As opposed to these last ones, we can describe dark nebulae, black and gray clouds, which rarely affect the light of other stars. They can also be called as absorption nebulae, a name that surely suggests their main characteristic. As a matter of fact, they don't produce or scatter any type of visible light. Composed of molecular hydrogen and helium, they can only be detected observing other frequencies such as microwave or infrared. Usually they observe the view of a backward emission or reflection nebula. These nebulae are probably the densest ones in the entire universe, and giant molecular clouds, which are the biggest existing dark nebulae, can surprisingly reach the ridiculous length of 150 light years. This means that in order to go through the entire cloud, moving hypothetically at the speed of light, you would take nearly 150 years. Compared to our own solar system, which is around 2 light years, this distance is totally crazy. And it doesn't end there. Do you want to know something more exciting about dark nebulae? They are one of the coldest objects in the universe, reaching the very low temperature of 10 Kelvin, nearly minus 263 degrees Celsius. Moreover, it has been studied that the center of this nebulae might be a region of stellar formation. The shape and the structure of a dark nebula can be surprisingly fascinating. Have you ever seen that shocking photo of dusty clouds resembling a horse? That is Horsehead Nebulae, a dark one in the Orion constellation. Finally, we can conclude our journey through nebulae with the last, but not the least type, supernova remnants. What are they? They are produced by a supernova explosion. Two different paths can bring us to such an energetic phenomenon: black holes and neutron stars. The first ones are probably the most famous astronomical object, being an ultra-dense collection of matter that has such a strong gravitational force that neither light can escape from its attraction. On the other hand, neutron stars are visible and are really dense too, consisting of a central core of degenerated neutrons. What does this adjective mean? The particles are so near each other that a strange quantum phenomenon takes place. The nucleus of the star generates an outward pressure called degeneration pressure, which balances the extreme gravitational contraction that would make the star collapse. Both these objects are the result of the collapse of massive stars, more than 8 solar masses, that have finished the nuclear fusion in the core. The collapse of the star generates a shock wave with expulsion of material, which is the supernova. The remnants of this tremendous event are accelerated to an incredible velocity of 30,000 kilometers per second, 10% the velocity of light. With time, the materials slow down to the speed of sound, and they form this unique type of nebula, which is considered the main source of cosmic rays. Do you know what they are? They are particle beams that reach the Earth from different positions. If you want to know more about that, please check another video in this channel in which we go more deeply into cosmic rays. Probably the most famous supernova remnant is the Crab Nebula, a stunning cloud in which we can easily see the materials expelled by the supernova. To sum up, we have seen a wide variety of nebulae, different in their origins and compositions. What seemed just a dense cloud in space revealed to hide some important features for astronomic research, such as star formation. That's all for this video.